Okay, these are the notes for section 3.5. Now there's two things going on in here. We're solving these systems. First part is graphing. Second part is by substitution. Now graphing, first of all, I would only graph on my graphing calculator. If you start graphing parabolas by hand, it's almost impossible to get them accurate enough to really see what's going on. So there's different things you have. Some of the problems are going to have a parabola and a line. And you'll be able to tell, like if you look at, for example, number 1 here. You see how this one's got an x squared, so that's a quadratic, so it's a parabola. This one has an x squared, so that's quadratic, it's a parabola. So this one's going to have two parabolas. This one here, notice it's got an x squared in the first one, so that's a parabola. This one doesn't have an x squared, it's just got an x, so that one's a line. So that's your choices here. So if it's a parabola and a line, if they don't touch at all, that's no solution. If they just touch at one point, it could be like this, or it could be, you could have one that's off to the side like this, where it's kind of tangent to it. That just touches one point. And of course, you could have where the line goes right through the parabola, so it has two solutions. Sometimes there'll be two parabolas. Well, they might be like this, where the vertex of the up parabola is above the vertex of the down parabola. So those do not intersect, so there's no solution. Or it could be like this, where they only intersect at their vertices. So that has one solution. Or they could be like this, where they overlap and have two solutions. Okay? So to solve those by graphing, now I changed this first one. This is not the same one that's on the note package you got. I did not like that question, so I changed it to this one. Again, as I mentioned, I would only do these on the graphing calculator. It's too hard to get them otherwise. So you want to go to your graphing calculator, and the first thing you want to do is go to y equals. So you can see on here, so you press y equals, I'm at y equals. Now enter that in. So x squared minus 4x plus 4. So x squared minus 4x plus 4. So enter that one in. Then go down to y2 and put the other one in. Negative x squared plus 4x minus 2. And you can do this on the Desmos calculator that you have on Canvas. It should work very similar to this. So now they're both in there. Now I'm going to graph that. So you can see there's a parabola. There's a second parabola. So this has two parabolas that overlap. Okay? I'm not going to sketch them on my paper right now. Normally I would sketch them on the paper, but I'm not going to do that right now. So now we want to find out where those 2 points, so it has those 2 points of intersection, we need to find those. So on your calculator, you're going to go second calc. So I'll write that up here. So we're going to go second calc. Remember the calc is up here above the trace button. So there's the calc right there. Then notice number 5 says intersect. So we're going second calc intersect. So here I can press number 5. Now it's going to ask me 3 questions. It's going to ask you first curve and second curve. That's because you can graph as many graphs as you want on one, but you can only find the intersection of 2 at a time. So this way it lets you pick which ones you want. If you notice right now, that cursor is on that upper parabola. That's y1. So that's our first curve. Well, we only have 2. When it says first curve, you hit enter. Now notice it jumped. You see now it jumped down to the other one now. It jumped down to y2. So when it says first curve, you're going to hit enter. And when it says second curve, you're going to hit enter again. And now it's going to say guess. Now we have 2 points. We can pick, we only do one at a time. But when it says guess, like if you see my cursor there, see my cursor's right over here right now. I'm going to move close to that left point. I'm just going to find it first. So it doesn't matter how close, just somewhere over there near that point. And now hit enter. And it should tell you the answer. So it says that intersection point. See at the bottom it says it's 1, 1. So that's one of our answers. 1, 1. Now repeat that for the other one. So again, second calc. So second calc, we want to intersect again. First curve, enter. Second curve, enter. Now when it says guess, let's move over close to the other one. Let's go over to that one and hit enter again. It should tell me that point, 3, 1. So that gave us our two answers there graphing. Again, that's one's different than the one in your packet, but I changed it. Let's do the same thing for number 2. Now notice number 2 has, this one's going to be a parabola because it's a quadratic. This one's going to be linear. So we want to put those in our calculator first. So go to y equals, I'm going to clear off those two. Now, so we're going to enter in x squared minus 2x minus 1. So x squared minus 2x minus 1. The second one is negative 2x minus 1. So negative 2x minus 1. So we've got both of those in there. Now let's graph it. So there's the parabola. There's the line. Now see here on this side, it's hard to tell whether where it touches that line in twice or once. We don't know for sure. So now just like we did before, we're going to go second calc. We want intersection number 5. First curve, enter. Second curve, enter. Guess. I'm going to move it. It doesn't matter. I'm going to go a little left of where those points are. You can see my cursor's up here. So I'm left of that point, just somewhere left, and I'm going to press enter. Now, if you see what it says right here now, you see how it says 9.1882 and then e to the negative 7? That's scientific notation. So remember, that means 9.1, let's round it off to 9, times 10 to the negative 7. If you wrote that out as a decimal, that's a decimal and 6 zeros, and then 919. So that is a really, really small number. It's close to 0. In effect, it actually is 0. For some quirk in the calculator, the way it does these computations is it gets that answer, when the actual answer is 0. Whenever you get one and you see that e negative something, negative 9, negative 7, that answer is 0. So here, when it says that intersection point is there, that is actually 0. So x is 0. And notice the y is negative 1.00002. You might have got a negative 0.999999 something. Well, that's really close to negative 1. The actual answer is negative 1. Again, it's a quirk of the calculator. If you plugged it in, the actual answer is 0, negative 1. If I tried to go on the other side, if I repeated what I did before, let's go for second calc, intersect, enter, enter. Now, if I go guess on the right side, let's see what it says there. Notice it's got negative 2.08 e to the negative 7. So that's roughly negative 2. And then y is at negative 0.99999, so that's negative 1. I'm sorry, that's still 0. Sorry, I'm thinking wrong. So at negative 2, that's still 0. So there's only 1 point there, 0, negative 1. Okay? So that's solving by graphing. Do them on your calculator, second calc, intersect. Now, the solving by solutions. I made a change there too. On your sheet, I moved number 4 over here to number 3. On your sheet of notes, this one that I moved over here, this one that I moved here, that's actually your number 4. I moved it over here. Now, if you don't look at this one, notice there's a y in this one and there's a y in this one. There's two ways to do this when you see a y, a plain old y, not a y squared, a y in each one of them. You could solve this one for y, like this one here. If I got y by itself, it'd be y equals 7 minus 2x. Now you could take that and plug it in right here for y. That works fine. Or you could take this top one. I could solve it for y. let's say I moved the y to the other side. So I moved y so it was positive, and I moved the 5 over here so it looks like that. So now these are my two equations. Since it's y equals this and y equals this, these two, we need to find out when these two are equal to each other. So let's set it up like that. X squared plus 2x minus 5 equals 7 minus 2x. Now we want to get it equal to 0, so let's add 2x. So that'd be 4x. Let's subtract 7, that's negative 12. So we got it equal to 0, so we can solve it. Now, there's like at least 3 ways you can do this one. I always look to factor first, and this one will factor. If you don't want to do that, you can complete the square. If you don't want to do that, you can use the quadratic formula. Any of the 3 ways work fine. I like to factor first, so I'm looking for 2 factors of a negative 12 whose difference is 4. Well, that's 6 and 2. Since the 4 is positive, I want the bigger one. I want the 6 to be positive and the 2 to be negative. Now, if we set each of those equal to 0, we get x equals negative 6 and x equals 2. Now, we're not quite done because we still have to find y. Let's take each one of those and plug it in here. So right here I have y equals 7 minus 2x. So if I plug in negative 6, that's y equals 7 minus 2 times a negative 6. Well, that's 12. So 7 plus 12 is 19. So one of our answers is that when x is negative 6, y is 19. Do the same thing with the 2. Plug it into that equation over there. So that'd be y equals 7 minus 2 times 2. Well, that's 4. 7 minus 4 is 3. So when x is 2, y is 3. That's the other solution. That's what you do when you have just a plain y in each one. Now this is the one I added. This is not in your sheet, so this is a different one. Notice this one, this equation has only squares in it, x squared and y squared, and this one has a plain y. When that happens, we need to take this value here, so your y value is all of this. We need to plug that in place of the y up there. So we still have x squared. Now in place of that y, we're going to put negative 3x plus 10 squared. We just took the y out and put a negative 3x plus 10 in its place. Now we need to multiply this out. Now remember, that's like a negative 3x plus 10 times itself, negative 3x plus 10. So if we distribute there, we have negative 3x times negative 3x. That's 9x squared. Then we have a negative 3x times 10. That's a negative 30x. And in here we have 10 times a negative 3x. That's a negative 30x. Then we still have this. 10 times 10 is 100. Our equation looks like that. Now let's combine like terms. We have x squared and 9x squared is 10x squared. Negative 30x and a negative 30x is a negative 60x. And they are 100. This is supposed to be a 10 here, I'm sorry. That's x squared plus y squared equals 10. I knew there was something wrong there. So this is plus 90. Sorry, I typed that in wrong when I redid it. So it should look like that. Now notice these are all end in a 0. So to make it smaller, let's divide this whole equation by 10. So it looks like that. Now again, you can do that by factoring, by completing the square, by quadratic formula. It doesn't matter. I want to factor that because it will factor. So x and x, 2 factors of a 9 that give me a negative 6. Well, that's a negative 3 and a negative 3. So if I set that equal to 0, I get x equals 3. Now again, we have to find y, so we're going to put that 3 in right here. So we have y equals a negative 3 times 3 plus 10. Well, that's a negative 9 plus 10. So y equals 1. So that means our solution is the point 3, 1. Okay? So that's all that's in section 3.5.